Our next speaker is a former CEO and co-founder of Kobojo, a European leader in the social gaming industry. For the past few years, Vincent has been living in Krakow, where he has founded EVERYDAYiPLAY, a successful game studio specialized in free-to-play games for a mid-core audience. He is also self-proclaimed business angel and free-to-play consultant and a learned startup enthusiast. Please welcome to the stage Mr. Vincent Vergonjeanne.
Thank you, sir.
Bring it on.
Thank you, guys. Thank you for being here. It's a small crowd, but I hope you guys will get some value out of this thing. So let's see what's going on here. Here we go. So I'm going to talk about WebGL. And WebGL is a big deal. I don't know if you guys have heard. There was a thread in the company email 2 days ago that Chrome officially announced that now the death of Flash is announced for Chrome. Well, not 100%. Basically, they still said the top 10 domains will still get it activated by default, but pretty much everybody else will get Flash gone. So we are in an era of massive transition when it comes to web. In terms of technology, and company like EVERYDAYiPLAY, and maybe some of you guys, if you guys are here, maybe you're concerned, we really need to check out what's going on with WebGL. And it's not been very pretty for the last years, but I have good news. So Olaf, oh wait, here it is, it doesn't work, hello? My computer is dead, what's going on? Here we go. It's very strange. Here we go. Oh, here we go. Yes. Ah, here we go. Sorry. Przepraszam, jestem Francuzem, nie mówię bardzo po polsku. All right. So yeah, Olaf already kindly introduced me. I work for Kobojo. Kobojo quickly was doing casual games. We were like the French Zynga, so-called, with the same faith as Zynga. It was a nice and very epic adventure, though, and I moved to Krakow 3 years ago, and we co-founded with Radek, with art director, EVERYDAYiPLAY. We've made 2 titles so far: Vikings Gone Wild and Heroes of Paragon. Yeah, and that's awesome. But we're not here to talk about me, but to talk about WebGL. So, why is it so important to us, this WebGL conversion? So, I'm just going to have a very short introduction of our story before we jump into technical detail. Basically, October 2013, we launched Vikings Gone Wild on Facebook. And because of that, and because this is where we launched, we are in our DNA, a web company. The game was massively featured by Facebook, and we launched basically, thanks to Unity, a hybrid Flash and Unity web player. We launched on mobile 1 year later, but at this point of 2013, we are making most of our revenue on the web. June 2014, we basically started a new game, Heroes of Paragon, and it's obviously planned to be launched on web player. Flash is gone because Unity said, Flash sucks, we won't do it, we have something for you, but for now it's just Unity web player. So, well, web player, why not? Turns out we actually had a lot of web player already using, a lot of player using web player on Facebook, which did a very good job to promote that technology. And obviously iOS and Android. Ta-da! April 2015, Chrome officially, and they were talking about it, so we can't say we were not aware of it, but we never thought they would actually execute this madness. They killed the NAPI, the native API, which is basically as old as the web, and was basically created so that you can run an actual DLL in a sandbox mode inside your browser. And it's what makes Java possible, this is what made web player possible, and a lot of this technology. Obviously, it has an immediate impact on Vikings Gone Wild, which unfortunately at the time had 70% of its traffic on Chrome. Oops, with a huge amount of those people using web player. They were kind enough at the time that it was not an immediate kill. There was a way to re-enable it. So a lot of people moved to Firefox, and actually we met with the people at Firefox after, and they were like, oh, we're so grateful for Chrome for what they did. We got so much more browser downloads thanks to that. So, but they were like, we don't understand what they did. It was not ready at the time. So it kills our plan to release Heroes of Paragon. Without the web player and Chrome, which was the major, there's really no point. And I have this town hall meeting like with everybody, and I can announce we officially became a mobile company. We have, because of Unity, we have no future on the web right now. So, you know, Unity announced throughout this world meets that they are preparing a WebGL output. I'm like, ooh, okay. So we managed to get our hand on this 5.0 beta at the time. And we fight a bit to export the game. We run it, and it's a disaster. It's a disaster. This stuff either does not even launch and crash immediately the browser starting the game. It's insane to think that a web page could crash the browser that hard. In 64-bit, the stuff will pass, but we will have 2 frames per second. Absolutely horrible. Like, there is no way out. On top of that, the size of the project was massive. Things were not optimized. We're like, we're doomed. There's no way. This is not going to work. Obviously, in April, so we're like 4 months later, when officially stuff goes down, 2 weeks before we know it's going down, we're like, let's try, right? We absolutely need to get this WebGL stuff working, otherwise it's going to impact us. And same results. No, we are really a mobile company. So the breakthrough came from our contact at Facebook. And because Kobojo was a Facebook company, EVERYDAYiPLAY, first title, Vikings on Mars, was a huge Facebook featuring. I have very good connection over there. That's kind of our unfair advantages. And basically we talked to them and they're like, Vincent, you need to try again. It's October 2015. And they say, well, I'm put you in touch with those guys of my team in Palo Alto. And in preparation of this conversation with the engineer of Facebook in Palo Alto, or Martin, our CTO, give it a shot. And oh crap. It works. He comes back, he works until 5 in the morning, comes back at 12 and said, Vincent, you need to come here, check it out. And we have a game running 30 frames per second that actually didn't crash loading. Well, almost didn't crash because turns out very randomly, literally every time on most browser, the game will crash randomly after 2 or 3 minutes running it. And nothing really consistent, just like the browser crashing. Looking closer to it, we basically see a huge memory leak, memory going. So, but it's encouraging, right? And we know actually we're just about to talk to the Facebook people who apparently must be connected. And talking to them, they basically introduce us to Mozilla people and Unity. And that's really where we really decide to commit ourselves to get this stuff pushed. So from prototype to release. And I'm going to show you a quick demo of this thing that you know. Can you switch to my other, or maybe I can move this somewhere? Wait, I'm sorry, I'm going to try to push this on your screen. Oh yes, here you go. So this is the game. This is pure JavaScript. Output of, wow, beautiful, it works. This is JavaScript, 100% JavaScript running in the browser. And the first time I saw that, I was like, holy crap, this is awesome. And I'm just going to try to get into a battle quickly. I don't know if I have anything ready. Let's go here. Okay, that's not going to go very far, but whatever. But just so that you get an idea of the kind of 3D JavaScript can do. So the guys at Mozilla, when they saw this demo, they were like, oh my goodness, we want this. We want this very bad. So we made actually a nightly build for them. So we have a version that works completely offline that they are using. And the guy at Unity at the time were like, what? This is awesome. And so even the guy at Unity didn't believe this was possible with their stuff at the time. Okay, well, apparently it's not working so great right now. I know why, because I'm on. Where's my mouse? Okay, yeah, so I have a saving mode on my laptop because I'm not plugged right now. But trust me, on an average PC, this stuff works really, really nicely. Let's get back to that. So let's talk about the details, okay, and what we had to do to actually transform this early prototype that kind of works-ish, kind of crashes after 2-3 minutes, and make it work. The crashing after 2-3 minutes, it's something they fixed after 2 weeks, something that was halfway on Unity and halfway on Mozilla, so it was great to have both teams cooperating on this thing. But there is a lot of stuff we had to go through, and I'm going to share with you today. So the first thing is that there is no raw socket in WebGL. And when you make a web game that you know you can be hacked from the client side, you know you need a freaking server if you don't want people to kind of cheat everywhere. We're using actual sockets. We thought we were smartass. We actually use a port 80, so you know HTTP port, but we have our own custom server that runs at the back so that we can have a TCP/IP connection between the game and not be dependent of the kind of HTML protocol. So so we basically install Sockify. Sockify is something pretty cool, and it was very easy to do. The way it works is that it basically encapsulates your raw TCP/IP stuff into an HTTP. Cool. Go through over HTTP by the browser, and WebSockify basically maintain that connection and unpack and actually connect himself through a TCP/IP connection to your server. So on our server we have tons of IP coming from the mobile that connects directly, and we have a lot of 127.0.0.1 basically coming from inside, coming from WebSockify. That worked like a charm. It took us not more than 2 days to actually get this full HTTP bridge to work. And I'm going to show you quickly, it's just that simple. You have your socket and you just use a WebSocket line of code. You can see that they are very close to another, and job done. That's it. From the implementation on the Unity side, that was that easy to do. Just a little bit of trick on the WebSockify, setting up to talking to our server, but really straightforward stuff, surprisingly. So socket, check. The other stuff is thread, no thread support, and that really hurts, especially when you have a game like Us, which have you seen? It's a real-time strategy game, which has a lot of AI going on. So what happened when we removed that AI thread or pathfinding thread? Because it's kind of convenient to have your pathfinding CPU usage on the different thread than your rendering, right? As you render, we can compute stuff on the sides. So we had to kind of optimize some of the stuff, especially pathfinding. We had to kind of put some extra love because now everything is, kind of sequential. We tried to make it, to be able to run into multiple frame, but it was just too much work. So the best thing we could do was just optimize the crap out of this pathfinder, so that it doesn't take too much time on that frame, because now everything is on the same thread. Network in general. So once you have this WebSockify stuff done, well, there's still a couple logic that needs to be tweaked for the chat and in server communication in general. So the trick is simple. Typically, you have a thread that's open that has a blocking read, and as soon as something comes in, it reads, unpack, and then just loop back up and wait. You can't do that anymore. So trick is simple. You remove the blocking read, and every update you check if there is something to consume. Something? Nope. Okay, I'll come back. Fairly straightforward as well. If you have questions, please raise your hand. If this is can be a communication. Bundle loading. So it's something that if you have done mobile games, you could be familiar with. We had a similar issue when we were doing Vikings Gone Wild on mobile. the early loading of the game of Viking and on this game was basically done on a single frame. So on a single frame, we're basically loading like a lot of stuff. And the premise is this is what happened here. Basically, by default, the browser will say, "Hey, I've got a sign of your stuff for a long time, so it's probably an active loop. It's probably dead. Do you want to kill it?" It's like, this is the death of your program. Obviously, if a user sees that, it's super user-friendly. Like the script is buzzy, you may stop it. It looks kind of almost like a virus or something. I mean, it looks really terrifying. There's even a debug script. Oh my goodness, poor people. So the only way to remove this was to make sure everything was spread over a frame. So every frame, basically, you let the browser says, "Hey, I'm done here. I'm here. I'm here. Don't kill me." And it's the same thing on iOS. Actually, if your program doesn't talk for 10 seconds, I think iOS will kill your app, saying like, "He looks dead. Let's kill it," because I prefer to have a better user experience of my OS rather than an app that is completely unresponsive for more than 10 seconds. So, same issue there. Yeah, so let it breathe. Same thing with custom files. So for this game, Heroes of Paragon, we have a lot of custom file where we have the stat of the guys. We have something called so-called runes. There's 600 of them, so those are like really massive file. And same story, those files were all like kind of put into one frame to be loaded, and same issue. So again, every single file you want to load or put in memory, just every frame. Rendering. So as I mentioned earlier, we had already a good start, 30 frames per second, but that was with some kind of an empty village and kind of the tutorial map. As soon as it went to really fat battles, the frame rate will drop immensely, and so there is more work to be done there. And so we found a trick that worked really well for us. I don't know if there is an official name for that. It's probably a technique that is used by other people, but it worked great for us. We call it custom batching. So, there's multiple ways. You can do static batching or dynamic batching. Static batching, pretty much to sum it up, will take everything you say that is static, we'll make it one mesh at the beginning of your launch, and we'll never ever touch it because it's static. It's a single mesh, so it runs faster. There's no submodule. Hopefully, you can even optimize the texture to even make it one and make it even rendered in one call. But if things have to be moved for a while, that doesn't work great. You have the dynamic batching, which basically every frame is going to try to figure out what can be batched and what can be put together. It works great. Actually, Unity does a good job at that, but dynamic batching also takes some CPU time and some GPU time. It takes some time to figure out which one is batched or not. And sometimes it does a really crappy job at it because things are not using the right property, or it's not the right type of texture, or there is a misconfiguration. So the custom batching idea is basically to have the best of both worlds. We take everything that we can render at once and make it static. For example, in our case, all the village that you saw, all the stuff are technically an independent mesh, and because they can be destroyed. But at the launch of that level, we make it static ourselves. We make all this mesh in one. Up until, something trigger that one of those buildings is exploding. If we do so, then we kind of mark it as dirty, remove that building, and recompute a static mesh out of this stuff without the missing building. And that worked really well for us. We saved everywhere. We saved in render, we saved in CPU needed for batching, and in many ways it was the strongest frame per second optimization we did for the game. That was very much WebGL friendly. Player preferences, this is not true. I'll pass on that anymore. This has been fixed. Pre-memory allocation. So basically when the game has to be loaded in memory, the browser needs to know how much memory needs to be allocated for this JavaScript to run. And it has a, I think, default value of 512, but you can override this value. And so we had to find a sweet spot. When we first started testing the game, you need to remember that we decided to basically port this web player version, this WebGL version, literally 3 weeks before hard launch of the game. We're supposed to launch on mobile, and last minute we're like, okay, we can do this WebGL stuff. Let's relaunch on Facebook as well. So we had no time, and basically after 10-12 minutes of playing our game, the game will crash by lack of memory. And it will not be the browser. Browser will be completely safe here. It was literally just us going over that 512 limit. We had no time to really investigate what was going on here, so we tried to play a little bit with that allocated memory. Apparently we had a chance to touch it. So we decided to go for 718. Don't ask me why this number. That's the one we came up with. And so it worked for a while, but it turns out that, and actually we kept that until the launch. And on the launch, now that we had tens of thousands of people coming in, we started to have people saying the browser could not allocate enough memory for the WebGL content. So there is a side effect of this, that actually if you ask for too much, if you're on a 32-bit browser, or like, I don't know what kind of browser they had, or older browser, they could not, the browser itself decided, no, I can't allocate so much stuff, sorry, but deal with it. So our sweet spot was 600 megabytes, and that's where we really had the lowest amount of complaints. Seems apparently seems to be allocable and worked out. You need to know that on certain 32-bit browser, there might still be a cap at 512. So ideally, you might want to keep your game under 512 megabytes. Since we have fixed this 512 megabytes issue, I think the mistake we made at the time that the team was thinking it's going to be like a PC game, you know, so we can kind of afford more stuff than on the web because it's PC, right? We have more memory, more stuff, but it's not the case. So forget about the resource folder. So if you're familiar with Unity, you know that anything in the resource folder will be embedded in your main binary. And it's fine if it's iOS or if it's Android, because anyway, you should use its space, right? You have 100 megabyte on iOS that is downloadable. You have 50 megabyte on Android. I think they're talking to pass it. You can get it to 100 if you're in some conditions. And actually, putting as much there on mobile really makes sense, because it means that you don't have to pay so much for for a CDN to have extra content downloaded after the launch. People hate when they have to wait even more once the game is downloaded. So it's a good idea, but on the web, it's not such a good idea. I've been making web games for a while, and I can tell you that there is one rule. The smaller your initial binary until you can show something, the better, because the more people will stick. Especially in free-to-play, it's all about that retention, right? You want people to come back the next day, and you can lose a lot of people. Not because they don't like your game, they're not going to wait that long to interact with anything. So, as mentioned, 3 weeks before we decided to do this, we were a freaking mobile game. So we had a lot of stuff in this resource folder that we thought was handy. So we had to move everything out and basically move them into bundles. If we already had bundles anyway, because the game was way bigger than 100 megabytes, so we already had this full bundle system, which really saved us and made it efficient to transfer everything to that. But if you don't have one, then you might spend some time there to convert your mobile game into WebGL, because everything has to be bundleized to kind of streamline and shorten that initial load until you have a first interaction possible with the user, or at least a progress bar or something. When it comes to downloading bundles, we don't advise you to use this load from cache or download, even though it sounds great, right? It sounds like it's going to do everything for you. But we use the simple WW object downloading mechanism. Turns out this load from cache download produce some lags in the bundle decompression and definitely has a memory overhead that for us had an impact in performances, a noticeable one. So we stuck to the WW object and deal with this on our own. It was basically more efficient. Something to remember. For the full screen button, so keep in mind this our issue we had in December 2015. I don't know if this one is still the case, but for some interaction some interaction between the brother JavaScript and Unity, there was some issue here, and probably in the order of event being triggered. In this case of the full screen button, basically we're clicking on this full screen button, nothing was happening. Then we're clicking mouse up again on it, and then it was going full screen, as if some of the event was swallowed up. So we put that full screen event on mouse down and fix that issue. It's something very silly, but decided to mention it today if you struggle with this interaction with the brother. Now, debugging. Debugging is a tough one, and Unity knows it, and nobody really has on the very short term a solution, but everybody is working on it. Basically, the idea is that those brother was not meant to put in memory like a 60 megabyte JavaScript file. Yeah, JavaScript was never meant to be that. JavaScript was meant 20 years ago to be kind of a lightweight, very malleable, very non-hard type language that allows you to do some high-level interaction with your HTML kind of thing. So the 60 megabyte stuff is a tough one when it comes to debugging, and so there's no way to put a breakpoint there. It's not there yet. So one ugly way we found when you really have to do it, and so one good thing though is that you still have the console. You can still do your console.debug and get still a lot of information. I mean, if you've been a video game programmer, I'm sure once in your life you actually had to debug only with console output. So at least there is that, right? But sometimes even the console output is not enough because something is crashing and you don't really know where, and you want to figure out more stuff. So we found one way that really saved us out of a few things as a way to kind of put a breakpoint and make a break. So if you have your project in debug, we use Sublime Text because we tried a couple text editor and none of them could actually open such a fat JavaScript file. Only Sublime was able to do this without basically dying. And basically you look for your function name in there. It's basically your freaking code in a massive single file of JavaScript, and you can look for it. Look for it, add an alert or like whatever things you want to check that you will have done with a breakpoint. What's the inside of this value at this point right now? Stuff like that. And being able to step through it further than just a console could be very helpful, especially if there's a lot of iteration of this thing, and you're flooded with stuff and takes so much time. This really helped. It's not pretty, but it works. And so that's the conclusion on the technical side. From a business perspective, so the game was released on the 3rd of December. On Facebook, it was a WebGL only, and we launched on iOS and Android. And here are the early results we had at the time. Interestingly, we had a higher DARPU, daily average revenue per user, or average revenue per daily user, in this case, ARPDU. We had a higher ARPDU on WebGL than iOS and Android. Those numbers were slightly pimped up on the WebGL side because our existing audience was also Facebook, so we had a lot of kind of hardcore fan on that day. But it was an interesting thing that basically that WebGL 3 weeks later was mature enough to actually make money and actually be a commercial ready technology. The lower part was retention. For those who are don't understand this D1 and the word retention, the idea is that in free-to-play, you measure how many people actually came back the next day. It's a very important way to understand and measure the success of your game, because it's all about having people to come back. The game is free. So if they don't come back, they won't spend money. And getting that number is extremely key to understand how reliable. So these numbers are fully correlated with the performance, though. 45% of iOS, it's a very small park of devices with a very consistent amount of performances. So it's not a surprise that this stuff did better on iOS, because it was the same game everywhere. So it just meant that the game was more reliable on iOS. There was less performance issue across all devices. Second one is Android. Android has a lot more devices to deal with. So some do well, some do obviously less well. When you have this little phone that's supposed to run this 3D game, it's not going to work so well. And the last one was WebGL. So it was below 30%. And below 30% is okay. It's not great, but it's workable. And the truth is, for quite a while, this WebGL version still did, though, more money than the iOS and Android version. Also because we had more traffic on the web, but overall it was okay. One thing we did to actually improve that D1 retention was to have a web player hybrid. So remember Vikings Gone Wild launch, we had a hybrid solution of Flash and web player. Well, we did the same thing. And to improve our D1 retention, we basically had this hybrid loader that says, hey, can I run a web player there? Because we know web player is the most optimum thing, right? At this point still. So, you have web player. Wonderful. Well, I'm going to launch the game on the web player because it's almost like running a PC version. You don't? Okay, let's go WebGL. And that really improved our retention by 3-4 points, bring it way above the 30% number. Though obviously web player is meant to die, like Flash basically, I would say probably within a year. I think that Mozilla people told us that they announced the end of the web player or the NAPI by the end of 2016. So we still have some time, right? But it's going to come. However, in the weight of like the final improvement, and there are stuff coming up that are going to fill up the gap. What are the issues still? We still have a fairly fat JavaScript file today. We zip it as much as we can to kind of get it down to kind of 6-7 megabytes for Heroes of Paragon, but it's still 6-7 megabytes. And it's still quite fat. A good Flash game, we're talking about a game that was extremely popular, typically gets its loader around 4 megabytes. 4 megabytes is kind of a sweet spot on the web. Okay, technology of downloading has grown up as well, so this number has grown a bit, but the smaller the better. And there are stuff coming up. Specifically, the thing that is the most awaited and that's coming up hopefully soon is the WebAssembly. The idea with the WebAssembly is that I can code in C++, and it will output an assembly that is readable on the web. So it also removes the need to be JavaScript. So it means that you can actually kind of write in any language you want and still be web-friendly from a WebGL perspective. That will do many things. It will optimize performances, but it will also optimize the size. Because the size here is because we are freaking JavaScript, we are a freaking text file. So as soon as you can go binary, well, it's much smaller. And that's it, folks. That's all I have to share with you. Thank you, guys.
Thanks very much. We still have time for Q&A if it's okay. If anybody has questions, feel free to ask. Just raise your hand.
Okay, so first question about this memory. You told that it is not worth to try go above 600 megabytes because browser may not support it, but what with coming below? Isn't it, because I have this situation like on, I have recently tested a game I've exported to WebGL, and it worked for me when I have had open one tab in browser, but if I had multiple tabs with random content, went web pages, etc. And then I launched the same game. It just doesn't launch and throws out of memory error.
Was it a 32-bit or 64-bit browser?
I believe it was 64-bit browser.
I don't know, and the best in this is for you to check on your own. What I report is what we experienced in December for the launch of the game, and things might have changed. For sure, we saw that in 64-bit browser, which obviously don't have as much limitation memory than 32-bit for the reason you know, we didn't see much impact there. But definitely 32-bit browser were at the limitation that you just talked, because I think that binary cannot allocate more than 2 GB, if I'm not wrong, or something like this, or 4 GB, something ridiculous. So obviously, as soon as a tab takes 512, then the other one, maybe, you know, there's still this, you know, it might be trickier.
But is there any magical way to check how much memory your game takes in web player?
We do. Actually, our CTO Martin is often showing me those things. No, you know, actually, just open your browser. I mean, I don't know what OS you're using. I'm using Windows, and you know, you open the task manager and check your Chrome tab. You know, every Chrome tab is a different executable, so you can check. How your tab is doing as a separate thread. Sorry.
But will it not take always this size we declare on beginning? Always 600 megabytes?
No. Actually, it can go much higher. Actually, technically, during the decompression and the parsing phase, this stuff can go much higher. Our game, I think, goes up to 1 gigabyte, but because that's the browser, you know, that's not the memory he gives the game to deal with this, but that is an internal buffer to actually. So this stuff can actually grow pretty high, and so what you see there might not actually be the memory allocated to your game. It may also be a overhead for Chrome to still exist in the middle of this thing. But typically, if you open your task manager and look at your browser memory and launch your game, I'm pretty sure it will spike over 1 gigabyte of memory spent to basically parse the crap out of this massive Unity engine. It's a huge word of parsing and putting in memory every time, because it's not compiled. So it kind of has to recompile Unity every time you run anything, even an empty project.
More questions?
Go ahead, Chris.
I have actually two more. First one, this custom batching. I'm not sure if I've understood you properly. So you just mark during gameplay, you mark object as statics, and it just works.
So it's not marked. I mean, it's all internal technology. And could you put my screen back on? Reconnect. I'm going to show you on this. So the idea is that on that village, all those buildings are like, except for the moving part, but all the static part of my building, so this thing, this guy, not that door, all thing has been batched into one mesh. And I mean, this mesh obviously has a ton of codependency in terms of texture and stuff, but it's a single mesh, kind of like what static batch is what we're doing, right? But we made that static batch ourselves, you know, so we basically fed our own stuff, our own static batcher, if you prefer, and say, all right, this is going to be batch, static. And obviously during this mode, there's no explosion, so those buildings are going nowhere. So basically, we immediately save, because there's no batching anymore for those guys. It's a single render, and there's less sorting. There's a lot of improvement. There's less CPU. When we go into battle, let's say that this building explodes. Well, we mark it as the fact that it should be removed from the scene, and we static batch everything else without this guy. And this happened fast enough that you don't see any spike in the usage and stuff like that. And that really improves. So it's kind of like a middle ground between static and batching, because in a sense it's kind of a custom batching where we know what should be displayed in which order, and we make it static in a single mesh, yet with the capacity to remove things from it. Capacity that Unity by default, when you're static mesh, doesn't let you do it. So it's just that's about the idea.
Okay, thanks.
Anyone else?
All right, guys. Thank you so much. I hope it was helpful. Take care.
Thank you very much.
Do
Mr.
widzenia.
Vincent Vergonjeanne.